All right, let's talk multi-stage events. So sometimes we discuss probability in terms of events that happen in multiple stages. For example, what if we flip a coin, record it, and flip a coin again? Or what if we pick a card from a deck, look at it, put it back in the deck, and pull another card? Or what if we pick a card from a deck, look at it, and don't put it back in the deck and pull another card? These scenarios are multi-stage experiments that have to be calculated differently depending on whether they are dependent or independent events or mutually exclusive or not. So what's independent versus dependent events? Well, independent events are those where the outcome doesn't affect the future outcome. So in other words, it would be something where you replace something, so you put it back. The sample space or the outcomes will remain the same. So if you're in a rolling a dice experiment, obviously that's going to be independent because each time you roll the dice, you still have all the possible outcomes. If you're tossing a coin, same thing, because the outcomes of heads or tails are still there. But a dependent event is when maybe you don't replace it, maybe you leave it out, so your sample space or your outcomes don't stay the same. For example, remember the game Guess Who? If you said, does your person have long hair? If they answered yes, then you would eliminate everyone who had short hair. That's when your sample space changes. Or if it says something like, you pick a card, like you pick an ace, you don't put it back in the deck, and then you pick a jack, right? So that would be a dependent event. So events A and B are independent if the probability of event B occurring is the same whether or not event A has happened. For example, if a fair coin is tossed 2 times, the probability that the head comes up in the second toss is 1/2 regardless of whether or not the head came up in the first toss. Events A and B are dependent if the probability of event B occurs relying on event A occurring. For example, the probability that 2 cards drawn at random from a deck of playing cards will both be aces. If the first card drawn is an ace, then the probability that the second card is also an ace would be lower because now there's 1 ace already gone. There's only 3 left in the deck.